Dear friends, I want to share with you the recording of my first seminar, my first presentation in the field of science and theology, which I delivered nearly 10 years ago. Specifically, I delivered this presentation that you will now listen on February the 14th, 2015, at the Grandpont House, which is an academic venue in Oxford. Few months later, I started my studies in theology at the University of Nottingham. First, my MA, and then, few years later, my PhD in theology. I hope you will find my reflections on testimony useful in relation to the dialogue between science and theology. I will leave many bibliographical references in the description of this video, including the link of the YouTube presentation of Professor Simpson, whose reflections in 2015 inspired me on my research in the philosophy of testimony. I delivered the same presentation also in Italian few months later, precisely in May 2015. So if you prefer to watch my presentation in Italian, you can do that by accessing the link of the YouTube presentation in the description of this video. I hope you enjoyed this video.
Happy to have you here. Happy to have our speaker here this evening, Dr. Luca Settimo. I'd just like to give him a quick introduction before he takes us away with his talk. Dr. Settimo is a researcher in pharmaceutical sciences. He works as a clinical pharmacist in a hospital in Reading, and I gather some of you know him already, so you know all this. He was awarded a Master of Science degree in medical chemistry from the University of Padua in Italy, and a PhD in bioinformatics from Abo Academy. Is it Abo? Obo Academy in a university in Finland. In recent years, he's developed an interest in philosophy and theology, and he studied these disciplines in 2012 and 2013 at Blackfriars Hall here in Oxford, at the University of Oxford. Luca is also a student at the Interdisciplinary School for Science and Faith-Based at the Pontifical University of the Holy Cross in Rome. So he's everywhere. The title of his talk this evening is The Value of Testimony in Scientific and Religious Belief. And so if you join me in welcoming Dr. Settimo.
Thank you. I want to thank you, first of all, that you came here in the night of St. Valentine. So I don't have roses to give you, but I really appreciate that.
Wisdom.
Yes. So, thank you for the introduction. And as you know, I am a scientist. So this is actually my very first talk that I give in the subject of philosophy, of science and religion. I got very interested in science and religion living in Oxford for the last 8 years. And I managed to study this in different courses at the university, also at Blackfriars. And it's very common in the academic world in Oxford to see debates in science and faith. And I'm sure you are familiar with the debates, for example, of Richard Dawkins, with Alistair McGrath, for example, or with Rowan Williams. These are available in the internet, and you can see what is very clear to me, at least that's my impression, is that there is like a polarization, like a strong opposition, like the two are almost in contrast. This approach is very, very different from the approach that I have seen in the school in Rome, where I actually see a much more an approach where there is like unity of knowledge. So the science and religion are not like seen in opposition. Here you have sometimes the impression that people like listen to the debate and then in their heart they decide whether to clap the hand, either in favor of the atheist scientist or of the person that defends religion. So you really see a split. And on the sideline, if you're interested, this website, I'm maintaining a website for this school in Italy, the Interdisciplinary School for Science and Faith, and they also have funding that they encourage people to write articles. So if you are interested, just come to talk to me after this or send me an email. I want to quickly summarize what I have learned in this discussion in general in the Anglo-Saxon world and in Oxford. Usually the atheist scientist will use an approach where he will claim that the rational inference is the only method to gain knowledge in science. By rational inference, I mean a mixture of methods such as the deductive method. You think like ab initio, you start to think about a problem, like this is approach of quantum mechanics actually, or inductive method such as the empirical sciences. So you observe and then you derive the physical law behind what you've seen, or the logical reasoning, or the mathematical, or the inference to the best explanation. So all these are going under the rational inference and are very much used by scientists like Richard Dawkins when they debate with for example, Alistair McGrath or Rowan Williams. How do the Anglo-Saxon world answer to these anti-religious threats that these atheist scientists are raising? I have noticed in these talks, in this debate, two type of answers. So the first answer is that to deny that there is a contrast. So there is no contrast, and they say religion is perfectly in agreement with science. That's the first approach. And the second is to say that there is a contrast, but to deny that is improper. And I will now go through these two methods. So, as I said, deny that there is a contrast. This has been well presented by Professor McGrath. Professor McGrath envisaged almost the application of a scientific method into theology. And in fact, he published a book which is called Scientific Theology. So essentially using the canons of science into religion. Another professor here in Oxford is called Professor Richard Swinburne. This philosopher is actually convinced that the truth of Christianity can be shown by the fact that God's existence is highly probable, for example, by the fact that the physical law observed in the universe are regular and they are seen everywhere, so they are universal. So he concludes there must be a God. A similar approach in a way could be observed also from the medieval philosophy. So philosophers like theologians like Thomas Aquinas, for example, had different approaches, like the cosmological method. Cosmological argument is like proving God's existence from the first cause. Or then there is another, the ontological argument. This was introduced by St. Anselm. Or another one is the teleological argument. However, all these arguments I just mentioned to you, probably they can arguably show that God exists, but they don't say anything about God. God can be whatever thing. I did a research and I was able to find a philosopher here in Oxford that last year gave a talk at the E.R. Ramsay Center for Science and Religion. His name is Dr. Tom Simpson. I'm in contact with him, and he also gave me some feedback. And so this professor actually say, yeah, we can accept that there is a contrast, but deny that is improper. What are the ways that there are to know things around us? So I will say, and at this Dr. Simpson actually explained in his talk, there are 5 ways. So the first way is the perception. We learn things through our senses, like we see, we hear, we smell. All these things are things to learning about what's around us. The second is the memory. We remember things that happened in the past. The third one is what I was mentioning before is used very much in natural science is the rational inference, so inductive, deductive, inference to the best explanation. So very, I would say, experimental, you verify something. And then you have the introspection, that's the fourth one. Introspection means self-knowledge. You actually, you know how you feel, how you know yourself. That's a way of knowing as well. And the fifth way is the testimony. Testimony. We learn things, for example, by reading the news. We learn things by asking direction to, if you are in a city that you don't know, you ask information to a bus driver to go a direction. And I want now to make a very small experiment. So I will now tell a sentence, and all the people that were here last Saturday cannot say anything about. So last Saturday, I was here, and I was sit near Jim in that sofa. Now, for the people that were not here, can they raise the hand? Okay. So what I'm just telling you now is a testimony. This is a testimony I'm giving. So do you believe in it? Do you believe it? Yeah. Okay. So now you believe it, right? So what is the mechanism that you are using to say that you believe in it? What are the mechanisms? You could say, I don't believe it.
Trust that you're an honest person.
That's very good. And in fact, this is one of the conditions of testimony. So Dr. Simpson actually, as I said, point out that the testimony is a method to gain knowledge in case of historical facts or in events related to a revealed religion. And he's saying, yes, it's fine to use the rational inference. You can use it in science, but you cannot use the rational inference in the revealed religion or in an historical fact. You cannot. It's like you're using the wrong instrument. And so the way of knowing for believers in revealed religion is based in testimony and not in rational inference. That's the contention here. Please note that using this approach, I like very much this approach because this approach can make sense for the existence of a lot of doctrinal contents of the revealed religion. For example, we know from the revelation, from the Bible, some things about God, like many things about God. We wouldn't be able to get this knowledge using rational inference. Now, it's very good that some of you mentioned about the honesty, because I want to tell you the two requirements that are needed to be that need to be met in order to acquire knowledge through testimony. The first question to answer is when a person is telling something to us, we ask two questions. The first question is, does this person know what he or she is talking about? Yeah, that's the first question to answer. And this is also called in philosophical term epistemic authority. So is this person knowing what he's talking about? The second is this person lying in what he or she is saying? If we are sure that the person is honest and knows what he's talking about, so has epistemic authority, then we believe that the information that is communicated to us is true and constitute knowledge. That's the philosophy of the testimony. And this has been studied by different philosophers. And now if we go back in the 18th century, there are two philosophers that have studied testimony a bit, and these are David Hume. David Hume was a reductionist of testimony. So he was saying, this is what, very briefly, what David Hume was saying: if a person told the truth in the past is going to tell the truth again. So it's a very empirical approach about testimony. But then, if you're not happy, there is an anti-reductionist, and this is called Thomas Reid. He was a Scottish philosopher, and he is saying, he was actually arguing a lot with David Hume, and he was saying, actually, if we always use skepticism towards other people, we will never learn anything. You know, if you put in doubt everything, we wouldn't learn anything. So, like a child, of course, trust is, for example, his parents. That's in our nature. That's what Thomas Reid was saying. Now let's go to the testimony in religion. Testimony in religion is important because, as I said, a lot of doctrinal norms and information about revealed religion are transmitted in a very accurate way through written and oral testimony. Just few examples: the Ten Commandments, or the fact that Jesus asked to do certain action in his memory, are example of things that have been transmitted to testimony from generation. There is a philosopher called Cody that has studied a lot testimony in detail, and he concludes that he make a very long study, but he's concluding that, you know, if there are different sources or different witness for an event, like, for example, you know, people that were here last Saturday now can witness that I was here as well. So the people that are not here now, they can believe that. So that's an example of a witness because the event has been witnessed by others. So if an event has been witnessed by many people, it's more likely that it's true. And in fact, it's interesting that in the Christian tradition, we have actually 4 Gospels that, you know, come from 4 different traditions, and each independently transmitted the information. And it's interesting to note that there are concordances between these Gospels, suggesting that the facts that happened were real. Now, if we make an experiment here, and we don't do it, but if, you know, I start to say, you know, Chinese whispers, so it will be like a line of people and we pass the information. So what I will get in the end is completely different from what I said. And this showed that there is a problem when the information is transmitted like linearly. But it's better when the information is witnessed than is transmitted independently. Another example, this was written actually by a student in our school, a priest. He wrote about he comment about the resurrection, and he said that actually there is an important corporeal aspect of the resurrection, because what was so convincing for these disciples was actually that, you know, he evoked a body. It was not like, there are theories that think that the disciple had like hallucination due to the mental state, or, you know, some theory even think that there was the death of Jesus was only was not real. So that, but these hypotheses are not satisfactory because they cannot well explain the birth of Easter, for example. So again, the corporeity, the objective experience of the corporeity of Christ is actually interesting. Now I will go instead to explain about the testimony in science. I'm claiming that the testimony is happening also for the transmission of knowledge in science. And I will bring 4 case studies. Well, the first, the very simple one, if some of you are scientists here, I know some are scientists here. So if you go to a conference, you listen to a speaker, the speaker will present some data. He's not bringing the evidence there. You have to trust him. You know, perhaps he will have some slides that you will, you know, they will show what has happened, but then you have to trust that person. So if that, again, following the same rule I told before, if that person has epistemic authority, so he knows what he's talking about, and if that person is known by other scientists, is well recognized internationally, then the people are likely to trust what he's shown. Why he's going to lie to me? And so this is probably a very simple example that testimony is important in science. But now I want to bring some 4 case studies. So the first case study is actually the acceptance of the theory of the general relativity by Einstein, here mainly in the world, but through the testimonial role of a British scientist called Arthur Eddington. So Einstein published the general relativity in 1916, and as you can imagine, the theory behind Einstein was very, very, very complicated. The mathematics was extremely complicated, and you have to imagine these scientists were used to think in Newton physics terms. So so it was a big challenge to understand this theory and to believe it was true. And Einstein offered, interestingly, 3 observational implications for the general relativity. The first one is the deflection of light when the light passes near an object with a big mass. So the light gets deflected because of the gravitational of the general relativity. And this is called gravitational lensing. The second is the redshift in solar spectrum lines. So the light that is coming out from masses with high masses have actually the wavelength are getting larger when this light move away from them. This is called gravitational redshift. And the third one is the advance of the perihelion of Mercury. Perihelion is the point that the closest point that Mercury has to the Sun. And every other orbit, according to the general relativity, this perihelion moves. Now, Einstein was able to predict the advance in the perihelion of Mercury few months before he published the general relativity, and he was so happy. You should read when he discovered it. He was full of joy because he said, my theory works. And this actually, the fact that he was able to predict that fact actually gave reason to take the general relativity seriously. And this scientist, as I said, Arthur Eddington, was in love, essentially, with the general relativity. Some people went to look in his diary, and they found a sentence. So he testified that he was motivated to accept relativity more on metaphysical and aesthetic grounds than empirical. So he was already thinking it was excellent. That's the best thing you can do. And some people have actually studied carefully Eddington, and they find in the diary that Eddington admitted to have a lack of interest to actually prove that the general relativity was right. He was almost, saying, we don't need to show it. Of course, it's right. And on the November 6, 1919, there was, so after Einstein published the general relativity, there was an important meeting for the astronomers here in the UK, in London. And because they had to prove that the general relativity was right, and Eddington was forced to do an expedition in Brazil and Africa to observe the 29th of May 1919 total eclipse. So there was a total eclipse, and in that day they will measure the deflection of the light. And after this meeting that I have in London, they went through this data, and Eddington was convincing everyone that yes, there was a deflection of light. Einstein was right. And they conclude that this confirmed Einstein prediction and ruled out his Newtonian counterpart. So big revolution in science. You have to think that the Times in London on the day after, this is available online. I mean, you can search it, and I found it. the Times in London wrote an article on the 7th of November 1919, "A Revolution in Science, New Theory of the Universe, Newtonian's Idea Overthrown." As you can imagine, is a revolution. And so people that study this case actually discovered that the British scientific community put a lot of trust in Eddington because he was a brilliant scientist, he was expert in the field, and few people, very, very few people, Eddington was one of them, was actually able to understand the mathematics behind the general relativity. It was too complex. So they all essentially trusted in Eddington and another mathematician called Sitter. Only few scientists would have claimed to understand this work fully. So they have to, as I said, to trust this work. Other people have looked actually on the approach used by Eddington and discovered that probably Eddington was a bit cheeky because he massaged in a way some data, and apparently he left out some data from that eclipse. He actually wanted to to publish only what supported the general relativity, and so he knew precisely what he wanted, and he chose the data in accordance with one principle, whether or not it supported Einstein theory. The data set that did were in, those that did not were out. So some people think he was a bit cheeky there, but in the end we know that he was right, and general relativity works. And yes, the light got deflected. We know now from the galaxy, because the light can get deflected, they have a huge mass. So this is the first example. So you can really see that the testimony here play an important role in accepting this theory. Now, I have another example, which is much later, is in the 60s, and is a scientist called Joseph Weber. This scientist, interestingly, probably like Eddington, was also perhaps interested in the general relativity. He wanted to prove that the gravitational waves that were predicted by Einstein could be measured. He designed an interesting aluminum bar called Weber bar, where he claimed he was able to measure the change in the vibration within this bar, and he said that this signal peak, he published an article, and he said these signal peaks are attributed to the gravity waves. Now, I want to point out one thing here. The epistemic authority of Weber was much less recognized than the epistemic authority of Eddington. So Eddington, I look on the CV of these two scientists, and Eddington, when he was 22 years old, he was a senior wrangler. This, I discover, is the top mathematics undergraduate at Cambridge University, and was once regarded as the greatest intellectual achievement attainable in Britain. That's what is the senior wrangler. I looked at the CV of Weber, and at 24 years old, until 24 years old, he was a soldier. He was working for the army. So, epistemic authority, first thing, he was in doubt. Eddington had the advantage that his experiment could not be repeated easily. Why? Because it was a total eclipse. The next total eclipse after 1919 was in 1955. So there was no way to repeat that experiment. And so you can imagine immediately Weber, no epistemic authority, plus it's easy to repeat the experiment because it's an aluminum bar. I can do it as well, right? So other scientists tried to reproduce this result, and guess what? They were not so successful. So what happened? They put in doubt the credibility of Weber. They actually discredit his results. However, if we look back now, Weber gained back his epistemic authority, because last year, actually, at the Harvard-Smithsonian Center for Astrophysics, they actually reported the first direct image of gravitational waves. So there are evidence that actually he was right. He was right. I mean, probably he was on the way to fixing the experiment, but his intuition was right. I'm a scientist, and it is very important for the scientific community always to repeat the experiment before to accept a theory. We know that. There is no escape. Eddington, as I said, was in advantageous position because his experiment could not be repeated. Plus, the epistemic authority, if we know scientists, if a scientist is famous, we tend to trust him. It's like that. And I want to point out that both Weber and Eddington were both motivated by the beauty, again, of this theory of the general relativity. And interestingly, when a scientist like Einstein is doing well, when his theory works, of course, people start to believe. Scientists start to believe in his theory, because if he has worked with the perihelion of Mercury, he has worked with the deflection of the light near the sun, why is not working with the gravitational waves? So that's the approach we use a bit in science. We tend always to say, yeah, he must be right. We need to find proof that actually our hypothesis is correct. And so these examples, I think, show that the level of trust in theory play a key role in the acceptance of a theory. The third case I want to show is that a serious case of faking results, and this was happened in 2005 by a scientist in South Korea, a genetist, and essentially he published false data. His data were completely invented, probably driven by necessity of having funding for his lab. So what happened? The scientist discovered it was false, but this time was false. It was not like gravitational waves that perhaps, no, this was false. And what they repeat the experiment, an investigating committee was called, and they concluded that the investigative panel concluded this sentence. They said, this is a serious wrongdoing that has damaged the foundation of science. So you can see here, the foundation of science. So I have been thinking about these two scientists, this South Korean scientist and Weber. Weber, in my opinion, can be defined as a scientist driven by a dream. I'm not sure if you're familiar with Walt Disney comics and stories. In Italy, we call this Archimede, but I think in English it's called Giro Girlus. So essentially, it's one person of the comic stories that actually was always wanted to invent new devices to discover things. And for the first time, in fact, he built this device they wanted to detect these gravitational waves. I mean, eventually, some other scientists showed that they exist, but not with this aluminium bar. But anyway, the idea was good. Instead, the result faked by this South Korean genetist, they were bad. I mean, these were just false testimony, and probably the scientific community will never forgive this South Korean scientist. They will never forgive it, because he lost his epistemic authority forever, because if you publish something that is false, you stop out of a career. So, Walt Disney, we have Bassotti in Italy, and here they are called Beagle Boys, apparently. So just a sentence from John Hardwick, because I think with this case I want to show the importance of the morality of the scientist. It's very important, the morality. He said, if much of our knowledge rests on trust in the moral character of testifiers, then knowledge depends on morality. and epistemology also require ethics. In order to qualify as knowledge, many epistemic claims must meet ethical standards. If they cannot pass the ethical muster, they fail epistemologically. So, in other words, ethics, the ethical value of the person that is reporting the data is fundamental. And we could use the same thing also for the testimony in the religion, for the institution with the church. It's very important that that the institution that has a moral character, very respectable. The last one is an interesting case, I think, which is the fourth case, is the transmission of knowledge through testimony given by computer software to mathematicians, and these are the so-called computer-assisted proofs. So there are some powerful computer now that can be used to carry out difficult mathematical proof that no person has gone through. And the mathematician actually believe in that as knowledge. They don't put it in doubt because they would be too difficult to be run manually. And this constitutes knowledge. To make it more simply, if you take a calculator and if you make a very difficult long operation with a lot of number, you get a number. I guess we all trust that number, do we? Or do we want to show it manually? I think we do trust that. This is an example to show that scientists like mathematicians acquire knowledge through testimony, because a computer software that prove a mathematical thing, we are trusting it and we don't put it in doubt. So I want to conclude. So I tried to explain the role of testimony in religion and in science. I explained to you that a person decides to acquire knowledge through testimony from another person or from another institution only if these are considered to be sincere and in possession of epistemic authority. So if they're not lying to us and if they know what they're talking about. Both the moral character and the level of expertise of the testifier are critical for the transmission of knowledge. This, as I said, happened in the revealed religion, in the historical fact that has happened, and also in science. In science, knowledge is transmitted through testimony when three conditions are met, in my opinion. The first one is if the facts are not easy to be repeated or not easy to be verified experimentally. B, if these facts are understood and are verified only by a small number of experts. For example, they involve too extensive or too difficult arguments, and they are reported by scientists that knows what they're talking about. And the third is, as I said, the moral character of the person that is testifying. If these conditions are met, then also for scientists, we gain knowledge through testimony. I recently come to the conclusion that perhaps, also in our faith, we have things that corroborate our faith, like, archaeological things that support what has happened. However, I want to point out that the historical facts, such as the events that are important for a revealed religion, need to be witnessed and transmitted accurately with oral and written testimonial norms. These cannot be reproduced in a laboratory. So we cannot put the belief a test in a lab, essentially. In my opinion, this approach can make sense also of the existence and of the coherence of doctrinal content in the revealed religion. For example, all the things we know about God. I hope that I was able to show this different attractive method that shows that the religious belief in revealed religion, but also the transmission of some scientific data, are rationally evaluable according to testimonial norms. Thank you.